everybody. Welcome to the BCS Enterprise Architecture group this sunny evening here, where I am in Kent anyway. Welcome. We've got about 60 people signed up, so it's good audience participation. And we're going to be running for the next 45 minutes or so with Graham Burrisford, who many of you will know. He's given talks to us in the past, and he's certainly a familiar face to many of us. Graham's had a long career in IT. He was 8 years as best practice manager for a company that morphed and changed through its life from SEMA to Atos, and was the best practice manager for all the architects, analysts, and others other than project managers. And since then, he's been teaching the EA TOGAF and BCS Enterprise Architecture and Solution Architecture courses for 14 years. So he thinks he knows what he's talking about, which I'm sure is true. And Graham, interesting enough, plays football on a Monday night at 9 o'clock every night. It's quite late, so we're going to have to finish on time. So without much more ado, Graham, over to you, sir.
You want me to share my screen?
Yes, if you can.
Yeah, that's what I'm about to do.
Great. Excellent, I can see that.
Need to fill screen. Okay, so I know the meeting's time for 90 minutes, but I'm aiming to speak for 45 minutes. I've recently published 2 books, which you can see on the right there, and I've abstracted from that 10 5-minute videos and then strung them all together for the purposes of this talk. I haven't actually published them yet, so the YouTube version of this talk will be the first time they've appeared. You will probably not catch everything first time through, but then you can catch it later, and I might skip 1 or 2 of the sections. I did do.
Can you put it onto full screen at all?
Oh, sorry. Yeah. So I did have a rehearsal yesterday, which overran slightly, but it prompted me to put a brief preface before the talk, because enterprise architecture and system thinking are both terminology torture. Generally, a term means whatever people use it to mean, or it's defined in a domain-specific language. But the rehearsal showed that even within the small group I had, there were disagreements about what enterprise architecture means and what system thinking means. So today, I issued 2 polls to relevant groups in LinkedIn. I asked, what do you say an EA function is primarily for? Is it procurement of technologies, improvements and innovations in services and processes that use information, or whatever is done to steer and shape the business, anything that a business planner or a management consultant might do? And I can show you the results of the poll. The dominant answer there is the middle one, which is comforting because that's what I'm talking about. The business data application technology view of architecture, although system theory doesn't apply to the technology, it applies principally to the business and the data. I also asked in another group, which is systems thinking primarily about? Is it about modeling, designing, perhaps predicting the behavior activity systems, as in well-known methods, Cybernetics, system dynamics, business activity model? Or is it about human nature and how a self-organizing group of people in a social entity cooperate to meet some aims? This was a little bit unsettling because I found it was almost 50-50 in the system thinking group as to what it was about. Well, I say unsettling. It's unsettling for trying to give a talk like this. It wasn't entirely unexpected to me. So the focus in what follows is the first, it's activity system thinking rather than social entity thinking. I will touch on that more towards the end. So my position in a very confused world is that most EA sources and teams are looking to make improvements and innovations in business activities that use information. And that we should think separately about both social entities in which actors communicate, especially human actors, of course, and activity systems in which regular activities are organized. The science that most demonstrably underpins enterprise architecture is the latter. It's activity system thinking rather than social entity thinking. Another thing that came out of the rehearsal was somebody said, what are my sources? So I put a list of sources on the screen. Suffice to say, there's a lot of sources. And if you were to buy one of the books, you'd find lots more. And enterprise architecture, in the way that I'm talking about, has been pretty consistent in what it means since the 1970s. So here are the 10 5-minute videos. And the first is, what is a system and what is not? Some things called systems are passive classification structures like Dewey Decimal System or the periodic table in chemistry or the biological classification of species, but our concern is activity systems. Some systems have evolved by accident, like the solar system, but our concern is systems that are designed to meet aims. Some systems are closed, or at least you can have closed models of systems, but EA is about systems which are open. So the systems of interest, an open designed activity system is a pattern or behavior of activities that transform inputs into outputs, as a windmill transforms wind energy and corn into flour. More generally, an activity transforms inputs into outputs, and that's quite often represented in our domain in some kind of SIPOC diagram, suppliers, inputs, processes, outputs, customers, and or it has evolved or been designed to produce effects that no part can produce on its own. This is a big thing in system thinking, that the parts must collaborate to produce their effects, as in a ridden bicycle. The rider and the bicycle on their own aren't much use until they're put together. Some see the emergent effects of a system, which here is the forward motion of the bicycle, as the aims of a system. Now, actually, that's quite a philosophical debate about what the aims of a system are, which I'm not going to go into today. But suffice to say that some see the effects as the aims. Now, if we're going to say what a system is, and this is a weakness in systems thinking, that quite a lot of system thinking is just thinking, and it's not particularly about systems, we ought to know what is not a system. And Donella Meadows is an expert who has written a popular book called Primer in Systems Thinking. She says, it isn't any old collection of things. It's coherently organized. Is there anything that's not a system? Yes. A conglomeration of elements, a structure of parts without any particular interconnections or function. In other words, a group of actors interacting in regular ways to meet some aims is a system. But a social entity in which the actors act in haphazard or ad hoc ways is not a system. I'd like you to keep that distinction in mind. So is a system a structure or a behavior? A feature of system theory since the middle of the last century is its focus on behavior. So a system is a network of activities that relate in a pattern of behavior, rather than a network of actors that interact in a composite structure. What is a business? It's a social entity in which actors interact in activities to meet agreed aims. I've got a more formal definition on the screen, which I'll gloss over. Probably many of you in the audience are aware of TOGAF. Maybe you have a TOGAF certificate. It says in TOGAF, enterprise architecture regards the enterprise as a system or a system of systems. That's a little bit misleading. You may well say that is a vision of enterprise architecture, but a business, according to Donella Meadows, is only a system where and insofar as its activities are particular and organized. So I would say a business is more accurately described as an infinitely rich and complex social entity, and it participates in a mess of many discrete activity systems. And one of the jobs of enterprise architecture is to identify where there is mess and tidy it up. In fact, I think you could say that that was the original motivation for enterprise architecture in the 1980s, was to tidy up the mess of silo systems. Now, people, even respected gurus, often confuse activity systems in which activities are organized with social entities in which actors act as they choose. And management scientists often use the terms of activity system thinking, but with different, sometimes conflicting meanings when discussing social entities. Something to watch out for. So that's the end of the first video. The next is the most philosophical part of the talk, which is what is thinking, what is system thinking, and which starts with what is thinking. So I've drawn this triad after a French chap, Pierre Bourdieu, that captures some important elements of thinking. Thinkers observe and envisage realities. They create and use descriptions of those realities. The descriptions represent the realities. All we can know of reality is what we can describe and model of it. In other words, thinking creates and uses models of phenomena which are encoded in memories and messages. Knowledge is a biological phenomena, said a guru in this space, and I believe that's true. Too deep a thing for me to go into today. No model, no description, representation can represent every feature of the corresponding phenomenon. And you may know this in terms of the phrase, the map is not the territory. Mappers observe and envisage territories. They create and use maps which represent the territories. The territory is always much, much more than the map can represent. What we create by way of descriptions models are always abstractions. So much so that some gurus in this system thinking space say systems don't really exist in the real world. It's not my way of putting things. Yes, we create abstract systems, we create descriptions. Here's a description of the heartbeat. But then if we look at the world, we can see a heart which follows that description. It realizes that system. The heart is much more than a realization of that system, but that is at least part of what it does. So I think we can say there are abstract systems. They exist in the world. They are descriptions, and we can find realizations of those systems in real world behavior. Now, every abstract system is a perspective of reality, which you might say makes it subjective. It's the view of one or more observers. But it's important in science that it should also be objective. It's both subjective and objective, meaning we can verify it by testing that a real system matches the abstract system. So science, if we're to be scientific, demands that we test that the real system matches the abstract system. It's not always done in systems thinking, but it should be if it's scientific. Now that triadic model, actually there are several variations of this in philosophy, and this is the one I prefer. And I stuck with it for many years, but eventually conceded that this issue about the real world is always more than the system meant that I needed to elaborate the bottom right-hand corner. So abstract systems represent real systems which are instantiated by entities. The entity is always more than any system that it realizes. Which is significant in system thinking. I've got an example here of people observe and envisage games of poker. They create and use the rules of poker, which is our abstract system. The game of poker is a real system, but the real system is instantiated by a card school, which is always much more than any game of poker that it plays. Now, in human systems, a human actor may play two roles. They can play a role in a game of poker to realize the system, and they can also play a role in the card school, doing other things in the card school, and observing the game that they are playing. They can be an observer of their own system. That's called second order systems thinking, when an actor in the system is observing the system that they participate in. So what do business system architects do? They observe real business systems instantiated by businesses. They create and use abstract systems or models of them. They observe and envisage systems, they create models. They encode. To create and use is to encode and decode a model according to some theory of systems. So we need a theory of systems if we're to build a proper model of it. So we're going to come back to a theory of systems later, but I want to divert now into what enterprise architecture is. So next, what is enterprise architecture and what is it not? Well, we've said a business is a social entity, etc. An enterprise is a business. It can be a part of a business or it can be a group of businesses. What is enterprise architecture? Well, in the poll that I gave, there were clearly some people who thought that enterprise architecture is anything that a director or a management consultant might do to shape a business. But here we are, after all, in the British Computer Society tonight. It's centered on information use. It's first and foremost about where, when, and how business actors create and use information. It starts from what directors see as their mission, drivers, and goals. Now, I'm going to skim over this. You could, if you watch the video later, you can see a bit more discussion trying to clarify what enterprise architecture is and is not. The enterprise architecture we're talking about, the people who use the term enterprise architecture for the highest level business planning done by directors kind of deprecate and dismiss what we're talking about here as EITA, but it's always more than the technology. We're considering the drivers of the business, which prompt the declaration of goals, which are met by providing services, which are delivered by completing processes, which are performed by actors playing roles, which create and use data using apps that run on IT platforms. So the enterprise architecture we're concerned with, it should not really be dismissed as just EITA. It's much more than that. We always start with the business concerns. It's a lot of business and data discussion before we get to the applications and technology. And system thinking applies to the business and the data parts. It also applies to the application and technology, but that's not our focus today. So in this concept graph, typically directors are responsible for business planning, which I'm going to say focus on the top 3 of these 8 things. And enterprise architects focus on the bottom 5. They're overlapping the services and products. So if that's business planning at the top, you could say that enterprise architecture is business system planning. System in the sense we've been talking about, business activity systems in which people are playing roles. TOGAF has rather a nice graphic sort of confirming this separation of the business planning from the enterprise architecture function, and also relating enterprise architecture to other management functions, PMO, operations management, etc. And note that one of the difficulties we have, and it's one of the sources of terminology torture, is that each one of these has its own methodologies and frameworks. So as a TOGAF teacher, I know there must be 10 slides on which it emphasizes that you're not meant to use TOGAF out of the box and do it A to Z. You have to coordinate it with your business planning processes, your PMO processes, etc. And I've added into the corner a hobby horse of mine that you need, if you're changing human roles, you need a business change function, which a group of people who have their own frameworks. So in short, enterprise architecture is about the use of information in business activity systems. It involves describing baseline systems, describing target systems, planning and governing baseline to target migrations. It's the end of video 3. I want to return now to what system theory best fits enterprise architecture. And it's cybernetics. What system theories are there out there? Well, TOGAF, BizBoc, and other frameworks have a system theory of a kind. They have a set of artifacts which are more or less related to each other. TOGAF has a menu of artifacts which it's just kind of assembled from the bottom up. It's not really stitched together in a very coherent way. So where's the science behind this? Well, cybernetics was a major milestone in system thinking history. Later, we'll look at some other theories. Cybernetics is about the use of information in activity systems. Well, that rings a bell. The person who coined the term defined it as the science of control in the animal and machine. He said, we have a controller which senses the state of a controlled entity and gives it direction. So it's monitoring and controlling the controlled entity. The person who popularized cybernetics was Ashby. He saw a system as both a set of interrelated state variables and a set of behaviors that change variable values in regular ways. Well, of course, we maintain variables in databases. He wrote a book called Design for a Brain, I think maybe published in 1952, in which he pitched the brain as the controller of the body. The body has various variables like water concentration and salt and pH values and things like that. The brain collects data from sensors about the variables and sends data to motors to fix them. And homeostasis was a big thing early on in cybernetics. So I want to talk a little bit about system state definition. A state variable is a quality or concept whose value changes over time. For example, our ridden bicycle, the state variables include speed and direction. The system's current state is represented by the current values of its state variables. A system can have a micro state in each part has its own. Here we've got Sam saying the mass of each ant. It can also have a macro state. You can aggregate the masses of all the ants to say the mass of the whole colony. When we come back to system dynamics later, it deals only with aggregate properties. So to direct a target entity, a controller or regulator must monitor the target and or its effects, like a thermostat senses the temperature of the air and sends a message to a heater to switch itself on or off, or to amplify or diminish its strength. And the rider on a bicycle is continually getting feedback from the bicycle as to its speed, direction, and balance, and making tiny little movements to correct it. So the good regulator theorem, an entity must have a model of its target. Another source today, that's going back to the 1950s, what I was talking about there, still all valid. A modern source, Principia Cybernetica Web, says cybernetic concepts include system environment boundaries, input-output flows, processes, hierarchies, state information, and also the good regulator theorem that the controller must have a model of what it's controlling. Well, can we find cybernetics in enterprise architecture? Where does cybernetics appear in enterprise architecture? Togaf, in a throwaway sentence in business architecture, suggests some techniques you could use, and one of them it throws into the pot is structured analysis. Now, the authors of Togaf assumed that everybody knows what structured analysis is, and after whatever it is, 13 or 14 years of teaching Togaf, and I can assure you that the majority of people on a Togaf course don't know what it is. So what is it? Well, it's got some familiar concepts. It's got the concepts of cybernetics, system environment boundaries, input-output flows, processes, hierarchies. And it has the concept of mapping these logical systems to the actors, the organizations or roles that realize them. Structured analysis divides a business into logical functions. I'm going to take the dangerous step here of saying functions or capabilities. There's another argument to be had there, but trust me, it makes little difference what you call them. Here we decompose the functions down to the atomic activities at the bottom. Now, it's not just a hierarchy. We're interested in how the functions interact by flows, informational material flows in structured analysis, and how the activities, which are not sequenced in the hierarchy, are sequenced in processes. So we can demonstrate in a process model that the activities, how the activities connect in a sequence. So here's a toy functional decomposition diagram. If you want to call it a capability map, you can. And this is a hierarchical structure. It's a nice overview, and it does have some uses. But it's not really a system. It's just a composite structure. A system is not any old composite entity. It's a particular pattern of behavior, a set of interactions. So we have to look at the interactions. And I'm going to look at a case study developed by a chap called Tony Markatos in the States for the manufacturing part of this picture. Tony encapsulated all the activities of the manufacture products function and defined it in a big box there with suppliers on the left and consumers on the right. He then decomposed that to the next level of functional definition. Each of these functions in system theory terms is a system. It's an input to output transformation. And then he looked inside the fulfill orders and decomposed that further to another level of decomposition. This is only a toy example, of course. When you try to do this for a real business, you get hundreds, if not thousands, of bottom level activities, and it's quite an exhaustive process. It's not done as much as it used to be done, I think, because people found that it took a lot of effort to complete it to exhaustively and with consistent information up and down the hierarchy, and they couldn't maintain it. So I'm not really trying to sell you on doing this in exhaustive detail, although you may do it occasionally here and there. I'm just trying to explain that system theory, there is a science behind this, and it's cybernetics. What's the primary view of a system? Is it a network of actors who interact? Or is it a network of activities? I've drawn two different diagrams of the same system that we're talking about. Well, the primary view in structured analysis is that it's connecting the functions or the activities by flows, and we can map those. Oh, note, yes, I forgot to mention. Note, there is an input to output feedback loop. We sell more products, we're going to have to request more materials. The volume of the output affects the volume of the input. And we can map the activities to the actors that play them. Generally speaking, this is a network of activities. How do we understand networks? The human instinct is to impose a hierarchy on. We do this with organization structures, most obviously. Almost all organizations, business organizations, have a reporting structure whereby you can go upwards from yourself to the CEO. We impose hierarchies on activities or abilities. We draw a function or capability hierarchy, a logical structure describing the business. We can do this for goals as well. We can have a goal cascade, high-level goals decompose into low-level goals and objectives and so on. Now, in the classic way of structured analysis, you can do as many hierarchies as you like, but any two of those hierarchies could be drawn into correspondence. So you could say we'll have a goal for each unit of the organization structure or a goal for each function. It's entirely as you choose. So more on cybernetics here. The information maintained by business must be accurate. The controller must know the state of the actors and activities in the business. Now, you may have heard of the Zachman Framework. Way back in the 1980s, John Zachman envisaged storing all business data in a single enterprise database would be a good idea for exactly the cybernetic reason that we have in one place, we know the state of all the actors and activities of interest. It's remarkable how far we've deviated from that over the years. we have lots of data and the need for master data management. I'm going to dwell on this a little bit here. Initially, we had accidental duplications. We were developing lots of silo systems. And then we started buying packages, and they also held the same data in them. Then we decided to copy that data into data warehouses and data marts and restructure it for analysis purposes. And then we found that there are some naturally bounded contexts where the data really is discrete and doesn't connect, like HR and CRM and product management. And then in recent times, we've decided to make the situation much worse by dividing what could be a decent application. Ian West has entered. Dividing what could be a single application with a single database into microservices. So we've exaggerated the data disintegrity in the problem and the need for master data management. What about self-organization? What about changing the system? Well, in Cybernetics, Ashby proposed what we need to do is to couple the system to an observer who can maintain the description of the system and observe when it's deviating from desired behavior and correct it. And that's in effect what the enterprise architecture function is doing. It's monitoring the effectiveness of the control systems. It has a repository describing those systems. It changes those descriptions and deals with the migration from the old system to the new system. So there's a pretty thorough correspondence between cybernetics and what's going on in enterprise architecture. That's the end of video 5. Lorne, how long have I been talking? Do you know?
Yeah, you've been going for about half an hour, Graham. Okay.
Well, I'll definitely skip one of the sections in the next set. So there is something else in another theory and system. It's actually related to cybernetics called system dynamics. And it seems many people only know of system thinking through system dynamics, especially in the States. And it reduces systems to just two things, stocks and flows. A stock level is an aggregate quantity, like a wolf population and a sheep population. A flow is badly named. It's not really a flow, it's a change. If we increase the wolf population, what change do we make to the sheep population? Well, we reduce it. If we increase the sheep population, we can increase the wolf population. That's called a balancing loop. Stocks can be related by reinforcing loops, which are ever increasing or ever decreasing, or balancing feedback loops. In homeostatic systems are basically balancing loops. So in this predator-prey system, if you look at the values of the state variables over time, you'll see that they go up and down. They're oscillating around a homeostatic norm. They're slightly out of step, the two populations, but I think you get the idea there. Now, we have these ideas out of cybernetics of what's called self-organization, and some people equate the idea of complexity with what's called a non-linear system with a feedback loop like this. Biologists observe systems and they speak of self-organizing systems such as a flight of geese or a flock of starlings or a school of fish or a predator-prey system. And sometimes they call those complex adaptive systems. Perversely, many of those systems can be described in a simple model. The behavior is entirely rule-bound. They never change. Their outcomes are deterministic and inexorable. So the term complex adaptive system is somewhat misleading. It has a meaning in science, but it doesn't intuitively mean what you think it means. Difficulties finding in building these models are first finding all the stocks and flows. So wolves eat sheep. Well, sheep eat grass. Now, where does grass come from? Well, it's an organic entity fed by sunlight and rainfall. Where does rainfall come from? It comes from clouds. And we can go on to relate the sunlight and water vapor and clouds. And you can go on forever. And if you built a model of the universe, you would go on forever. So deciding when to stop building your causal loop diagram, this is called, is an issue. Not being entirely certain that you might have missed something really important. It's a closed system, you might have missed something. Quantifying the rules. You can't actually predict anything from this diagram. You have to quantify the rules and then run a simulation to see how the system behaves. And there are limits to stock. So although it looks like the sunlight and rainfall just keep on growing grass, well, there's a limited amount of Earth's surface. So eventually you've got the whole of the Earth's surface is covered in grass. Chaos theory comes in. You know about chaos theory. And however we limit the model, there's always likely to be something outside the model that has some unexpected effect. All of which means using this model for prediction is very difficult. Now, we've had some very recent experience of this difficulty with the COVID, the pandemic, with all those modelers who were firmly believed at the beginning, and by the end of the period, their predictions have been wrong most of the times, and quite often outside of even the upper and lower range that they predicted. What's happening is that unforeseen things are happening. In this case, we've got a farmer who's got a shotgun shooting the wolves and is putting fertilizer on the grass. All kinds of unexpected things can happen that disturb our model. So there is quite a strong school of, if you like, modelers for whom system thinking is system dynamics, and it does have its uses. I'm sure it's the basis of climate models and weather models and so on. But some of those people look at our systems and they go, oh, yours isn't a system with feedback loops. It's just a straight through process. They dismiss our systems as linear. Well, it's not fair, really, because you can find feedback loops. We had one earlier in the structure analysis example, and we can identify loops in variables in the system. The trouble is that drawing these causal loop diagrams is deceptively easy. Now, on the video, if you want to go back over this, I've got a couple of slides trying to explain the limitations of this kind of modeling, which I'm just going to leave up for a few seconds, so you've got time to stop it if you want to watch it on YouTube. The unfortunate thing is that in the system thinking community, sociologists and management scientists have latched onto the terms used in system dynamics like nonlinear, chaos, self-organization, and complex adaptive system, and use them with different meanings in discussion of social entities, human social entities, often with no particular regular behavior pattern in mind. And many draw causal loop diagrams with little understanding of system dynamics. So you will find on the internet scores of examples of these diagrams. Here's one of the COVID pandemic that I got recently. People draw these diagrams to tell a story, deliver a message, convince somebody of something. They're quite unreliable. The practice is more art than science. And a chap I consult whenever I need expertise on system dynamics called Will Harwood says if a person is building a CLD but not part of as a system dynamic model, he means with all the maths behind it, then what they're doing, they're drawing a pretty picture but not much else. And I'm afraid a lot of these are just pretty pictures. They may contain some lessons of interest, but they aren't very scientific. So a bit on system thinking babble. Where did system thinking go wrong? That's a controversial, provocative statement. Well, it went wrong by abusing scientific terms and concepts. By using them with different meanings. Let me make a few points here about holism, which is often presented as the be-all and end-all of system thinking. An emergent property is an effect, result, or ability that arises from interaction between things, like forward motion arising from the interaction between the rider and the bicycle. What does holism mean? It does not mean, and I see this over and over again in system thinking discussion, we must think about everything and connect everything. It doesn't mean that. It means analyzing or designing how properties emerge from particular interactions between particular things. So here we could take the bicycle, think about the emergent properties we desire of a bicycle: forward motion, steering, balance, comfort, warnings, and model. I've only done it in text here, of course. Which parts of the system must interact to produce those emergent properties? Holism means identifying the interactions that produce one or more emergent properties. Doesn't mean thinking about everything. Does holism mean synthesis? Synthesis is another sort of buzzword in system thinking community. You can't analyze or decompose a whole until you've bounded it. You can't synthesize until you've identified some parts. Nobody in the real world does analysis without synthesis or does decomposition without some composition. In the real world, people building models are continually flipping up and down the abstraction stack. Does holism equal holism? I've spelt out here what I was saying before. A holistic view does not contain or describe the whole of a material or social entity. It contains only the particular interactions that lead to whatever emergent properties are of interest. We cannot endlessly zoom in. We obviously get to a point where we say, that's atomic. I'm not going to look inside that. And we cannot endlessly zoom out. We can't widen our system boundary forever, including more and more things. We have to focus on what is relevant to the emergent properties of interest. Another thing people sometimes say is holism means we can ignore the parts. Well, it doesn't really mean that. And in fact, holism is sometimes implied to suggest that we should make whole-scale transformations of a business, that a good thing is to take a business and radically transform it. Well, McKinsey have done some research into this, and 70% of business transformations fail. And in practice, most modern advice is more on the agile side of things, that major improvements emerge from making many small incremental improvements to parts and how they interact. So I've got a little bit more on quotes I've taken that just aren't true from system thinking discussion, which are too much for today, so I'll skim over them. The fact is, we're always, in building a system model, we are necessarily abstracting. So system thinking went wrong when people started abusing the terminology. We never consider the whole of a material social entity. We cannot synthesize everything. We always abstract. So a little bit about abstraction, and I'm going to skip most of this. Abstraction, encapsulation. Four kinds of abstraction are found in enterprise architecture: composition, delegation, generalization, and idealization. I'm not going to explain them all here. If you're a TOGAF user or a student, you may remember the enterprise continuum. The enterprise continuum is a matrix of generalization against idealization. These four kinds of abstraction, you may think I've just made them up, but if you're familiar with Archimate, the modeling language, it's got a symbol for each of them. One of the difficulties with Archimate is the richness of the symbols and the number of ways you can connect two boxes. It's got lots of ways to do it. So that's the end of video 8. So I've got 2 more to go. The first is the soft-hard distinction. A conventional narrative in system thinking discussion goes along the lines of, there was a first wave, sometimes called hard systems thinking. Then there was a second wave, soft system thinking and second order cybernetics. And then there's a third wave, and here the guru places whatever they fancy talking about, including old ideas like critical thinking and design thinking. Whatever they fancy is the latest thing, the latest and best thing, which is superseding what was there before. In fact, the first and second waves are still with us. First wave ideas, Ashby talked about a system as an I/O transformation in which human actors may play roles. He talked about the abstraction of the system model from the real world. He said that different observers may abstract different systems from the same entity or phenomenon. And he talked about self-organization. So we've got the regular activities, the heater, we've got the monitor and control activities, the thermostat, and then we've got the change activities, the thermostat setter, who can change the controls, change the rules. In the second wave, Peter Checkland's soft system method, goodness, it's got all of the same ideas in it. Each of those cybernetics ideas reappears in the second wave, and people don't realize that they were already there in the first wave. Particularly, stakeholders may abstract different systems from the same business or situation was always a fundamental idea in system thinking. His activity models include not only the core do activities, but the monitor and control activities and the change planning activities. Very, very similar to first wave thinking. For me, the hard-soft distinction is much less fundamental than the one I'm drawing between activity systems, a network of actors, activities, and a social entity, which is a network of actors. The rules of poker are one thing, a card school is another. The score of a symphony is one thing, an orchestra is another. We need two kinds of thinking. So I've dwelt on activity system thinking. And here I want to emphasize that there's a many-to-many relationship between the entity and the system that realizes. So yes, a card school may play one game of poker, and one game of poker may be played by one card school, but really there's a many-to-many relationship. One card school can play many games of poker, and it can play other kinds of games. One game of the game of poker can be played by many card schools. There's a many-to-many between the entity and the system, in enterprise architecture, between the social entity that is business and the activity systems that are performed. One activity system, say the use of some software system, can be replicated in different businesses. So although I've emphasized activity system thinking, it is only one part of the story. We do need more. A business is a social entity that usually depends upon the ability of its human actors to act outside of systems, to make a judgment about what is needed and to do what is right for the customer, regardless of any system. So we do need activity system, which is about the realization of an abstract system in the real world. But we also need social entity thinking in human activity systems. We need somebody thinking about how the people are interacting and cooperating in the organization. Now, the truth is that although enterprise architecture frameworks include the organization structure amongst their artifacts, I've yet to come across an enterprise architecture function that actually defined the organization structure. That's usually considered a role for the business managers. So we do need social entity thinking. So the need for social entity thinking is the last section here. I've got a recap of things that we've covered earlier. Too much for today to repeat. What about social entity thinking? We can ask about a human organization. We can think about the micro aims of the individual people and the macro aims of the organization. We can ask how strongly are actors directed to meet the macro aims, and we can think how orderly is it? How far can the activities be modeled? How far can we take their activities and turn them into activity systems? Oh, that's interesting. 2 dimensions. This is my chance to become a management science guru and draw a 2x2 grid. I can talk about social entities as having high direction or low direction, and low order and high order. I can populate that with some examples. And my message that I'm delivering today, if there is a message, It's that enterprise architecture is at the top right of this picture, and sociology is at the bottom left, and that we shouldn't confuse the two. Both are needed in every business, but they're not the same thing. So most EA sources and teams look to improvements and innovations in business activities that use information. Even system thinking gurus confuse the social entity with the activity system. We should apply both kinds of thinking rather than confuse them. But if I'm looking for science, the science that I find that underpins enterprise architecture is activity systems, and principally cybernetics is the principal underpinning science. So there is a different kind of system thinking, more sociological. They tend to work with metaphors, and I've listed some of the metaphors that social entity thinkers and management scientists have used, and I'm not covering those here. I do give you an overview of them in the second of my two books if anybody's interested in buying them. So I'm not going to go on to talk about the books. I might do when I publish videos on YouTube. But that is the end, Lorne. Shall I stop sharing?
Thank you, Graham. Yes, if you stop sharing, and we can perhaps flip to some Q&A, questions and answers. So thank you very much. Gosh, you covered a lot of ground in quite a short space of time there. Thank you. Can I just ask you, in your own terms, practically, I thought that diagram at the end was very helpful, putting EA and sociology at two ends. Mm-hmm. In terms of EA as a practice, over the years you've been studying, what are the trends you see at the moment in terms of where EA is going, particularly as it relates to agile and all the new sort of ways that we organize ourselves?
Well, the agile guys are trying to reinvent enterprise architecture through SAFe,
yeah,
scaled up agile, which seems a monstrous thing to me. If you've got complaints about TOGAF, the bureaucracy and the fixing of roles in that it's quite frightening.
We've actually got a talk on SAFe on the 11th of May, so that's going to be interesting.
All right. Well, I've no first-hand experience of it, but looking at it, it is frightening, and it does look it does look like it's ossifying into a bit like what's that agile method that is it Netflix use?
Spotify,
yeah. which they made up for a marketing video and don't use themselves, yeah. And everybody takes it like a Bible. I'm going off the point here. Let me try and say some things. Well, one strand, which was why I did the poll today, is that strand of people who are always arguing with me in LinkedIn. Never, ever join an internet discussion group on enterprise architecture. It's the first lesson of life. But I'm in quite a few, and I get some people who are really quite opposed to the view of EA I presented here. And some come at it from the technology end because really they're just technologists, but that's a minority. The people who are most upset are the people who are using enterprise architecture for just any old management consulting they fancy. So I don't think that's a trend in the EA teams I know. I think the EA teams I know are still doing what you might call traditional EA, but there's certainly another school of people who are using the term EA for what I would say is just management consulting or business planning. So you can't stop the drift of words, but I'd just like to draw the distinction between the two.
Yeah, thank you.
But about agile, I don't think there's. I think the complaint about the agile people, well, that structured analysis maybe is interesting. There was a period in the 90s where people really tried to document everything in extreme level of detail, and they'd build a functional decomposition to 6 levels and have all the diagrams completed. It was just too much. So I think the biggest weakness in when I'm giving a TOGAF course, the biggest weakness, the thing I most feel nervous about is the enterprise architecture repository, which although you can find a repository useful and you can put useful stuff in it. I think the original vision of the single coherent model of the enterprise has faded and maybe never recovered unless it can be self-populating in some way. So I think that part of it has faded. And once that has faded, this idea that we're going to document everything in excruciating detail, like John Zachman has done, then you're left with a reasonably agile practice. You choose what you do and when you do it. I see agile, I see enterprise architects working in that kind of way, enterprise architecture teams contributing something valuable, but at a higher level than the software development project. So I'm not sure there's a great conflict between agile at the software development level and EA.
Great, thank you. So let's open the floor up to questions. If you've got a question, please, probably best is to put it into the chat actually, so that we can then parse it rather than have you unmute. So if you have got any questions for Graham from the talk, then please do sort of do that. And while we're waiting for questions, Graham, let me just ask you, another question. In the 14 years of teaching this and the way that the BCS works, what are the sort of changes you'd like to see over the next sort of year or two in terms of how EA is both taught and sort of practiced?
Well, this is an interesting question you raise here. The BCS Enterprise Solution Architecture Certificate, I was in the working party who created that back in 2008 and 9. And the BCS are currently revising that, but I'm not in the working party this time. So I'd like to tell you. Well, no, I think if I did know, I would have to shoot you if I told you. So I'm not sure I can answer that question. Was that the question you were asking, or was it more general?
Well, no, but it's more generally in terms of courses you run, and the practices. Where do you think that?
Okay.
Yeah.
There's almost no enterprise architecture function which quite fulfills the classical model that you might expect from even my own material. With covering the business data application and technology space, quite often one of those is missing. There's no data architect quite often. But what I do see is architect teams, and the function may not be called enterprise architecture, it may be called strategy and architecture team, with a pool of architects who are people who've been around the block quite a bit. And they may come from the business analysis background, or they may come from a technology background. Quite often they have a software development background, and the manager is utilizing that team in a reasonably effective way, but not in a very prescriptive way. And even the people who I taught a TOGAF class to an architect team like that, half a dozen people last month. They're not expecting to use TOGAF out of the box. They're expecting to use it in a flexible way, and they're expecting to merge it into their own processes. So I think people have matured a bit in their understanding of, what you can get out of this kind of any training that I deliver or any framework that's published. You do have to make it work for yourself. So I do see people doing that. And I wish I could say there was a completely consistent pattern. There isn't.
Yes, and a number of our members aren't yet enterprise architects. They many perhaps call themselves solution architects, or they come up, from different angles. Maybe they're data architects and things like that. What do you see in terms of the career path and the maturity of people coming into the EA profession and how all that works?
Oh, it's very. I see almost everything. Every time I ask, it's a different story. There aren't many patterns. I would say that, I teach the Enterprise and Solution Architect Certificate for the BCS, which I think is actually a better course for that audience than TOGAF. And it's certainly clear that people who come out of software development tend to have a leg up. It's something about the way they have to think in constructing the structure of software systems that gives them advantage. And I do get people who succeed very well coming from either end of the spectrum, sometimes in the business analysis spectrum, and sometimes even network engineers. But the business people always have a stretch at the technical end of the material, and the technical people always have a stretch at the sort of logical structured analysis end of it. So I think somebody coming out of software development seems to have a better handle on the breadth, if you like.
If you want to, what I'm going to do is I'm just going to go around the rooms and we'll just get a bit of sort of summary, if you like. So Robert James, as you were the man who complained about us not having enough dialogue, I'm going to ask you to unmute and say how that was for you.
Sorry, that was useful, and I had one point which I didn't think I could possibly make in chat, and that was about the use of Weltanschauung in David Checkland's model to actually provide a framework in which all the hard systems material could be rationalized. So I got the opportunity to make that, and having now shared that thought, which unless you have studied as I did with Peter Checkland, that may slip straight past you.
Great. Well, thank you for raising that. Yeah, it's interesting. Did you know Checkland well?
I studied for an MA under Peter and Dave and Brian Wilson at Lancaster in '82. Right. So 40 years ago.
Gosh, that's a long time ago.
It is. It's a very long time ago. One of the things I can say is that I always end up going back to his work and the various very simple concepts that he was putting forward, because his concepts were quite simple, and the ones which were brought out by his students and colleagues, and they formed the framework in which the harder material could, and from people like Stafford Beer and so on, could have a home, so that you could actually have a framework in which it all worked together. Right. So that was, I mean, that's very useful, and I always go back to it. I'm just sad that it doesn't form a larger part of the body of knowledge of enterprise and architecture and data architecture within the IT environment.
Well, maybe we could ask for a talk from you in the future, Robert.
I wouldn't suggest that I am knowledgeable enough to do that.
Right. Okay. Well, thank you for your contribution. So let me move to room 2. Ian, you're on the call. Do you have a sort of summary of what you discussed? Ian West. Is Ian still on the call? No. Yes. Here we are. Asked to unmute. There we go.
I'm here now. I couldn't unmute myself, Lorne.
Sorry. Right.
To be honest, I didn't do most of the talking. It was the Davids in the room who did the talking, but it was a bit more of a discussion about I suppose misalignment between things like enterprise architecture, data architecture, and trying to kind of addressing that, to be honest. That's kind of the main thrust of it, and can't really say much more than that, actually. I don't know whether David, I know he's still on the call, whether he wants to add any additional to that. If you'd like to unmute him, Lorne.
Yeah. Go ahead, David.
Yeah, so I'm unmuted now. Hopefully you can hear me. Yeah, my issue with enterprise architecture is the level of abstraction to agree. Now we're going agile between the business, the enterprise architects, the data architects, and the solution architects, because they all have a different level of abstraction that they need or would require to go to. And we also have to look at a global business as what data you share across jurisdictions and laws to do with GDPR and data sharing for marketing globally, which you may have not agreed with your clients to share personal details and all these sort of things. So your level of abstraction, your business rules, it can get heated to find out which level to go to with state, and they want to go agile. So that's my that's why I was in the room asking everybody's other thoughts and what their thoughts on that was. Because I always see enterprise architects and data architects as separate entities. Because if it's one person doing that role, there's always going to be a conflict of interest and pressure by the business. And so that, especially with data governance and compliance. So that's my understanding anyway. So
yeah, no, that's a good point. So Graham, you got any thoughts on that? I think you're on mute, mate.
I paint a kind of idealistic picture in my courses rather than in Toga. I've got a matrix in which I've got the 4 business data application and technology as columns, and enterprise solution and detailed design, or sometimes software architecture as rows. So it's a 4x3 matrix. And what I've done in private courses is use that as a trigger to say, how do you cover this space? I'm not telling you that you must have a role for each row or a role for each column or a role for each cell. I just want to know how you cover the space. And I find that's a useful device for them to get to think about, well, the missing data architect, for example, who's covering that space. So I don't think people do systematically try to cover the space and connect things properly. Things just kind of evolve. The roles kind of evolve rather haphazardly. And it's also influenced by the skills of the people who are brought into the team. So depending on where they've come from, that tends to be where they're utilized. Is that an answer to the question?
I think David's on mute, so you can come off mute.
Yeah, I'm trying to unmute myself. Yeah, that's very helpful. Thank you. Yeah, I'll have to have a look at that sort of matrix on roles to see, because it's everything, it differs, you see, because of the way the global business is. It's not something we could say it would happen at every instance and every time. So that would that matrix would change size and scope.
Yes.
For every sort of thing we're looking at. It's not something we say categorically it would always be that matrix for the business going forward.
Yeah,
it's always going to change, isn't it?
I agree, but I find it a useful device for prompting people to think about that space.
Yeah, thank you. Helpful.
It's on my website, but it's also in my LinkedIn articles. So if you looked in LinkedIn and found me there and looked in my articles, it would be the headline graphic in 1 or 2 of the articles.
Great. Thanks very much for that. I'll have a look around.
Yeah, I think the other thing, David, is that data can get very political. People put up walls and barriers around
Don't
data.
I know it?
Yeah. So I think the EA sociology triangle. I think you end up down the bottom left trying to work the sociology of the organization to actually unlock the data sometimes. Because it's people particularly sort of put their walls around it, but that's another topic for another discussion. We're doing well on time. We're going to end at past, but I'd like to move to room 3 if that's okay. And Massey, hang on, let's unmute Massey if that's okay. Massey, you had a few observations. It'd be great if you could share that.
Yeah, sure. We discussed the triangle that you had up, Graham, the one about description, realities and thinkers, and how you morphed that into a flow for abstract systems, real systems instantiated by entities and the business architects. We had a couple of people who, having had are settling into practical roles for that. We're quite interested in that. And what I found was a very new word for myself was cybernetics. And I think Lorne joined the conversation at that point and gave some insight on how that can be applied to like usefulness of machines. And what we would have liked to maybe have heard more of in your talk was maybe a bit more of an explanation on TOGAF from your perspective.
Oh, call me back for that another time, Lorne.
Yeah.
TOGAF in 45 minutes. There's a challenge.
Great, thank you, Massey. Yeah, no, we talked a little bit about the robot war, robotics, and cars as well, and cybernetics. So it's interesting how these systems that back in the 90s were probably quite theoretical and actually now coming through. So it's interesting how this stuff has grown so much over the 40 years that Robert was talking about. So thank you all very much for coming. Thank you particularly to Graham for giving us his wisdom. Graham, a few last comments, if you like, to sum up your views and what you've heard from perhaps some of the questions.
I don't know. I think I go back to that 4x3 matrix. As you do have to work as a team and without any gaps, and thinking about how enterprise. Well, at one place, a couple of times I've given talks, classes just to the solution architects, and sometimes it's quite frightening that there are enterprise architects, but the relationship between the enterprise architects and the solution architects is almost non-existent. The enterprise architects have disappeared into they're not really doing enterprise architecture long. I think somebody said it just on the internet the other day that they've retreated into attending advisory board reviews, and they publish some standards and principles and then spend their time in review meetings and never actually do any enterprise architecture. So I think getting people together in a room and deciding what they pass to each other and what they relate, how they interact, is a good idea.
Great. Oh, excellent. Okay, well, thank you so much. If we were in a room, I'd ask for a round of applause at this stage, but I'll clap.
Right. Okay.
But thank you very much.